Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
All right, so today we're going to look at trigonometry, something out of trigonometry. So we're taking a break from geometry and looking at triangle geometry or trigonometry, right? So trigonometry, anything under trigonometry deals with triangles and more in particular the angles within those triangles. What we're going to look at today is what's called angles of elevation and depression, right? And it's more or less an application to your trigonometric ratios, right? So you're going to be using something you should have already known, and those are your trigonometric ratios to solve for angles of elevation and depression. So it's a continuation of a topic, not necessarily a topic by itself, right? All right, so good. So I'm going to go through a recall of your trigonometric ratios. I'll try and teach you some new tricks. It might be new, you might know this already about those trigonometric ratios, something to help remember them. And then we'll dive into your angles of elevation and depression. And like I said, it's just applying these trigonometric ratios, right? These trigonometric ratios are what we're going to use mostly to solve for angle of elevation and depression problems. So this is something that you no doubt already familiar with, and those are your trigonometric ratios. I remember these ratios only apply to right angle triangles. That's something you need not to forget, right? Trigonometric ratios only apply to right angle triangles. So there are three basic trigonometric ratios that you need to be familiar with. There are more, right? They are more. They're not just three. There are I have at least been exposed to about 6 of them, right? Sine, cos, and tan are the only 3 that you need to bother yourself with, right? So you have sine ratio, cos ratio, and tan, right? And you should, of course, know that sine theta, remember theta is the notation for an angle. Opposite refers to the opposite sine divided by hypotenuse, refers to the hypotenuse sine, that the side that is the hypotenuse, and those are those trigonometric ratios. But just for the sake of clarity and memory, what I'll do is I'll actually just quickly brush over in a blackboard, just a quick blackboard session on your trigonometric ratios. So trigonometric ratio, like I said, deals with right angle triangles, right? And not just right angle triangles. Right? This is one of the things you need to remember, is that it only deals with right angle triangle. So I can write only in brackets here. But another thing that trigonometric ratios actually deal with is an angle. You notice all of your trigonometric ratios has sine theta, cosine, cos theta, and tan theta. So you need theta, right? So another thing that trigonometric ratios that needs, another criteria that you need to see in order to apply these ratios is theta, an angle. Right, so you need an angle. So you also need an angle, right? Angle, and that angle is called theta, right? This symbol is called the Greek symbol for theta, right? Theta. I'm not spelling correct. Perfect, right? Theta. That's theta. Good. So there are 3 trigonometric, well, there are more, but 3 trigonometric ratios that you need to be familiar with. And those are sine, cos, and tan. And those 3 are on your calculator, right? The others that are not actually on calculators. I've never seen a calculator with the others, and there's good reason for that. But the general idea for these trigonometric ratios is to use them to find either the angle, either theta, or the length of sides of a right angle triangle. So what you'll be using them for in most cases is on a right angle triangle. Okay? So you know them, you know your ratios, and those ratios are that, and they're called ratios mostly because it's sine theta is equal to some ratio, right? The ratio between one length and another on your right angle triangle. If it's the opposite, the hypotenuse, whatever the case might be. So the ratios are sine, you have your sine ratio, and the sine ratio just simply says sine theta, sine the angle is equal to opposite over hypotenuse. And cos theta, again, theta being the angle, right? I should put that somewhere. Theta is the angle. And what angle theta is, I'll get to that in a second. Right, so cos theta is equal to what, Rihanna? Rihanna was cos theta. It should be able to recall these right from
adjacent over hypotenuse.
Adjacent over hypotenuse, right? Cos theta is adjacent over hypotenuse, and then you have, last but not least, tan theta, which is opposite of adjacent, right? Good. So you have these trigonometric ratios you need to commit to memory. And what you notice that you need for your trigonometric ratios, you have the functions on your calculator. So what you need from your right angle triangle is one of these, two out of these three things: theta, the opposite, or two of the sides. You need either either the opposite hypotenuse or the adjacent, or you need theta. So you need to look for these three. Look for two of these three parameters, right, of your right angle triangle. Now, how do you find them? It's quite simple, right? And you more or less already know this, is that the angle is always theta, right? The angle is just an internal angle, theta, within the right angle triangle. And theta could be here or it could be here, depending on the information, the problem itself, right? So we have theta, good. And next we have opposite hypotenuse, and there's also the adjacent. So you got to be able to identify what the opposite is, what the hypotenuse is, and what the adjacent is. Now, one thing I want for you to recognize is that you can't identify your opposite and the adjacent without knowing what theta is, without knowing where theta is, right? You need to identify where theta is. And the reason for that is because the opposite side, what is called the opposite, the side that's called the opposite is actually opposite of theta, right? So the side here is opposite, right? Opposite is actually the opposite side to theta. So if you don't have theta in a right angle triangle, let's say theta was not here and I didn't identify any angle for theta, then you won't be able to actually use the trigonometric ratio unless you yourself identify an angle. And it could never be the 90-degree angle that's always there. So you always need to ensure that at least you will always see, right? Something that you might have noticed is that you always have an angle within there. Are you either finding the angle or the angle is given to you, but you're always looking at some angle within here, and that's what you use to label these sides, right? Nevertheless, like I said, we have our theta, and theta, the opposite side of the right angle triangle is called the opposite. So it's opposite to theta, right? It's always opposite to theta. The side opposite is always opposite to theta. So opposite, so the opposite, right? Right, like I said, it's always opposite to the angle theta. And if you don't have theta, you don't have an opposite, right? You need an angle. Now, there are, of course, the other sides, and those sides are the adjacent and the hypotenuse. Now, the hypotenuse is usually always the diagonal or the longest side of the right angle triangle. So the hypotenuse is always the longest side of the right angle triangle. Right, is the long, and it's usually on the diagonal. Right, it's usually on the diagonal, meaning it's usually like this on the slope, right? Diagonal lines, or sometimes it's not like there. Right? It's not there. But what you need to remember is that it's the longest side. So you know how to get, you know how to find the opposite, you know how to find the hypotenuse. The other side is called the adjacent. Right? And what the adjacent is, and the reason why it's called the adjacent, is because the word adjacent means next to, right? That's the simplest way to put it. Adjacent means that you're next to something. If I say the house adjacent to mine, it just means the house next door, right? If I say the house opposite my house, it means the house over the road or across from me, right? So adjacent refers to right next to, right? Adjacent to something, and opposite refers to over, right? Facing, you're facing each other means you're opposite each other. If you're adjacent, you're side by side, right? So the adjacent of the triangle is actually side by side to the angle theta, right? So the adjacent is, instead of being the side opposite theta or the angle, it's actually the side next to, okay? The side adjacent. I'm going to use back, I use back the word opposite because you know it by definition, but I'm not going to use back the word adjacent. We'll just say the side next to, right? Now you notice the order in which I labeled them, right? I identified the opposite first, then I identified the hypotenuse, and then lastly I identified the adjacent. And the reason why I did that is because it's easy for you to remember these two, right? Because if you remember these two, when you label these two, the other side could only be the adjacent because there's only 3 sides to the triangle. By method of elimination, you know that the other side is going to be the adjacent, right? So you don't necessarily need to remember that the adjacent is the side next to the angle. Once you know that the opposite will be the opposite side, the hypotenuse, the longest side, then automatically you would know that the adjacent is the other side, whichever other side is left unlabeled, right? So you more or less just need to identify 2 and you get the others, and you get the other one, right? Whichever 2 that is for you, whichever 2 that works for you, go right ahead. But that is in a nutshell what your trigonometric ratios are. And like I said, they're just ratios of these lengths equal to some trigonometric function to your angle, right? So all these ratios, you need to identify lengths and angles, right? You need to identify what angle you're looking at and the 2 lengths that are of interest. Good. So, and another thing, like I keep saying, they are only for right angle triangles. Good. So let's go ahead and do this practice problem. I'm just going to use 1 and 2, and the reasons for that will it's simple, right? When you're looking at a right angle triangle and you want to find any one of those sides, and you have an angle within the triangle, right? Trigonometric ratios should automatically come to your mind, right away. That's your best bet. It's the easiest way to find them, right? So what you need for your trigonometric ratio is actually just an angle or a side, or both sides or 2 sides, right? Now, how do you know what trigonometric ratio you have to use, right? The first step with approaching these problems, or knowing that you have to use your trigonometric ratios, is to label, right? So take your time, do this in steps. So first step is just to label what these sides are. So this side, the side opposite, that would be AB, would be the opposite as, right? And this would be the hypotenuse, as Bracker correctly said. So AC is the hypotenuse, and this side would be the adjacent, right? And the adjacent. Good. But you know that we have 3 trigonometric ratios, right? Sine theta. Remember, theta refers to the angle, and that angle is the one that we use to label, right? To label those sides, if you notice. Theta is always going to be the angle that we use to label each one of these sides, right? So if you have no theta, you cannot use your trigonometric ratios, right? Keep saying that over and over. These 2 things are your 2 criteria to using these trigonometric ratios. Needs to be a right angle triangle, you need an angle theta. Right? Or if you don't have theta, you can actually find theta if you know two sides. Right? Good. So we want to find side AC, and side AC is the hypotenuse. So what we need to do is to look at our trigonometric ratios to facilitate finding the hypotenuse, because we need to find the hypotenuse. So what you would do is look at a trigonometric ratio that has hypotenuse and an other known side, right? Another known side. We already have the angle theta, and that's fine, but we want to find the hypotenuse. And what's the other known side to us? We know the opposite. The opposite is 1 centimeter. So we know the opposite, and we want to find the hypotenuse, and we have theta. So we need to look for a trigonometric ratio. You can ignore theta because theta is in all the trigonometric ratios. But the two sides of interest to us are the opposite and the hypotenuse. Right? So you need to look for a trigonometric ratio that has the opposite and hypotenuse. All right, what trigonometric ratio is that?
Sir, sine theta.
Sine theta, right? So sine theta says that the opposite, that sine theta is equal to the opposite of the hypotenuse. Right? Now going it over again for clarity. Once you identify that you have a right angle triangle and you have an angle within it, one angle is not a 90-degree angle, that there is always a given. That's the only way you would know it's a right angle triangle to begin with, but another angle, right, besides your 90-degree angle. Once you know those two, once you got those two things, I want you to start thinking of your trigonometric ratios to solve, right? To solve for any side, any given side, or even the angle if the angle isn't given. So the next approach, label your sides, use the definitions that I would have given you, opposite, hypotenuse, and adjacent. Label those sides and then figure out which two sides, which trigonometric ratio you need to use. And the way you figure that out is to look at which two sides make sense to use, right? Which two sides are of interest to you, right? You have, of course, a side that you want to find, and that's the hypotenuse. And the other side of interest would be a known side, right? A side that you know the length for. Okay? And that in this case is the opposite. Right? So we're looking at the sides of interest to us are the hypotenuse and the opposite. Now let's go ahead and find the hypotenuse. So we know that we'll be using the sine ratio. And the sine ratio says opposite. Sine theta is equal to opposite divided by the hypotenuse. Right? Now let's just substitute for what we know. We know theta, and like I said, is always the angle that you use to label. It's equal to the opposite. The opposite is 1 centimeter. And the hypotenuse is AC, right? Let's use, instead of writing hypotenuse, let's use the notation, like AC. So we want to find AC. Now, to find AC, we need to, of course, make AC the subject of this formula and solve, because we can punch sine 30 in our calculator and multiply by 1, and we can solve, right? Now, what we need to do here to make AC the subject, of course, AC is in the denominator. So there's two ways you can actually make AC the subject. The easiest way is to just swap sine 30 degrees and AC, and you will get AC is equal to 1 centimeters divided by sine 30 degrees, right? You can actually swap those two, right? And with good reason that is mathematically possible and that is legal, right? You can actually just swap AC and sine 30, and you have AC now being the subject of the formula. Now, another way you can do this, again, AC is in the denominator, you want to make that AC the subject. Another way you can actually do this is to flip both sides. So if I imagine sine 30 is actually above 1, right? And you can imagine any whole number or any operation as being above 1. Right? So let's imagine that this guy is above 1. Another way you can do this, actually, I think this is easier, is if I carry across AC, All right, AC is dividing over here. I carry across, will be multiplying. So I end up with AC multiplied by sine 30 degrees is equal to 1 centimeters. And then, of course, I have to carry across this sine 30 because, again, I want to make AC the subject. Right? The reason why I carried AC across is so that it would be in the numerator. Right? Carry AC across, carry sine 30 across, we end up with 1 cm divided by sine 30. Right? Sine 30. And again, multiplication, you're multiplying. This operation here is multiplying. When it goes over, it's now dividing. Right? So be careful with your algebra. Don't forget your algebra. And that's what we would do to solve for this hypotenuse. Right? So you can now punch this in your calculator. Now you should get 2 centimeters. Please confirm. Confirm that AC 1 divided by sine 30 degrees is actually equal to 2 centimeters.
Yes, sir.
2, right? Good. So that is how you would go ahead solving for any one of these signs, right? Now, AC would be 2 centimeters. So now you know the hypotenuse is 2 centimeters. Right? And you could also go and find the adjacent. Right? So let's use the same, not the same formula, the same trigonometric ratio. Let's apply the same principles. Right? You know that, again, so we've already jumped forward, we've labeled it, we know that we're going to use our trigonometric ratio, so we've labeled our rectangle triangle, and now we need to go ahead and figure out which 2 sides are of interest to us, so that we can figure out which trigonometric ratio to use, right? So which 2 sides would be of interest to us? It would be, anyone can go ahead and which 2 sides would be of interest to us? We want to find the last side remaining, and that is BC, right? That's the adjacent. All right, so a lot of quiet persons like they're not sure.
Sir, the opposite and the adjacent?
The opposite and the adjacent. The opposite and the adjacent. So we're finding BC, right? This is the length. So the opposite and the adjacent. What trigonometric ratio is the opposite and the adjacent? Has opposite and adjacent.
Tan theta.
Tan theta. So you can use that, right? But if I argue that we can also use the cosine ratio, not the cosine rate, yeah, the cosine ratio or the cos ratio to solve for this as well, because we know this side too. Right, we know this side, so you can actually use either or, right? And you can actually, you will see that if you use either or, either the cosine ratio or the tan ratio, you will get the same answer, right? The same solution for this side. Okay? Now, rushing ahead, we will have to use tan, right? And tan says tan theta is equal to opposite over adjacent. So that'll be tan 30 degrees is equal to the opposite side. The opposite side is 1 centimeters divided by the adjacent, and the adjacent is BC, right? Again, you can use the trick that I just showed you. If you want to make BC the subject, just swap it with tan theta or tan 30 degrees. So BC would be equal to 1 centimeter divided by tan 30. Right? I believe this 2 will be 1. Let me check. Got about 1.7. We got about 1.7. Right? I'm gonna use it as 2 decimal, as 1 decimal place. Good. So you know we can find the other side. So and that's more or less how you would use your trigonometric ratios to find any side of your right angle triangle. And remember that you need your theta, right? You didn't need it, it didn't need to be there, or you can actually solve for theta, right? So let's say you're in a situation where you don't know theta, right? Theta is not given, right? So now we're looking at this situation. So not forget, but looking at this situation now, we have a right angle triangle. This is 1 centimeters, 2 centimeters, and 1.7 centimeters. We found those angles. Now, what we want to find is theta, right? So you have theta, let's label A, B, C. So in other words, I'm asking you to find the angle, right? By the way, this means angle. Well, not like this, that's some left-hand sign with it. This is a straight line, right? Not this is angle, right? Find the angle BAC, right? Find the angle BAC, right? Find the angle BAC, and that angle is here. So you label that angle as theta, and you find theta, and that's how you would use these trigonometric ratios to find an angle, right? Now, which trigonometric ratio would you use, right? And what would be your adjacent, opposite, and hypotenuse? So, right, so yes, I answer, you did get the hypotenuse correctly. That would be that side, but this side, because this side is opposite, is now opposite to the theta. What we want to find, or the angle that we want to find, which we're defining as theta, we would call this our opposite, right? And then we would call this our adjacent. The adjacent, or the A word, as you rightfully said, right? So that would be the labeling. That would be the labels. And once we know which sides are opposite, we know which sides are adjacent and hypotenuse, we can figure out which trigonometric ratio to use. Now we have all these sides, so we can actually, so luckily we can actually pick 2 sides, right? But just for the sake of discussion, I will erase the adjacent. So you don't know the adjacent. What trigonometric ratio would you use to find? What trigonometric ratio would we use in this situation?
Tan theta or cos theta?
Tan or cos? Okay, no, I raised the adjacent, right? We don't know the adjacent anymore. So the only thing we have.
My bad. It's sine theta.
Yeah, sine theta, right? I took away the, right? You could have used any one of them, but because I took that away, we need to use the sine. And the sine, I should have just erased the 2 anyway. So you know we have to use the sine again because we're looking at the hypotenuse at the opposite, and what trigonometric ratio can we use to solve for the angle theta would be a trigonometric ratios that has the hypotenuse on the opposite inside, right? And that is the sine ratio. It has opposite, it has that sine theta is equal to the opposite of hypotenuse, right? So sine theta is equal to opposite of hypotenuse. In other words, sine the angle ABC, right? You can rewrite it like that. Forgive this looking like a less than sign, it's angle, it's this angle sign, right? And the opposite is our 1.7 centimeters, and the hypotenuse is our 2 centimeters. And we can actually solve this. 1.7 divided by 2. I shouldn't need a calculator to do this, but 0.85 centimeters. Right? And then you have that this is equal to sine angle BAC. So angle BAC is equal to, well, sine angle BAC, not angle BAC, because we haven't found angle BAC, we found sine angle BAC. So you want to find angle BAC, that's what they asked us to find, that's what we need to solve for. So we're not done yet. What we need to do to find angle BAC, we need to make angle BAC the subject of the formula. And that's how you find any unknown in any formula. You actually make whatever it is you want to find the subject of that formula and solve for the other stuff. Just compute the other information. So the way we would make angle BAC, sorry, the subject of this formula is to actually transpose or carry over the sine, right? So just take over the sine and we would have the angle BAC left on this side of the equation. And when we carry over sine, it becomes sine inverse, what is known as sine inverse, right? Sine inverse, open bracket, whatever is left on this side of the equation. So what is left on this side of the equation? What's already on this side of the equation is 0.85 centimeters and close bracket. Right? Now, this is sine inverse. So again, we've transposed sine, right? We've carried the sine over the equal sign, and it becomes sine inverse, whatever was already over there, right? So sine inverse is 0.5 centimeters. And we can actually punch this in our calculator now. And these trigonometric functions, the sine inverse, the inverse of the function should be located right above or the second function of your sine, right? So it should be right above sine, and you can just use second or shift sine inverse, and you should get the sine inverse, right? Second or shift the sine, I should give you the sine inverse on your calculator, and just punch in open bracket 0.5 close, and you should get about you get about 58 degrees. Good. So we got about 58 degrees. Now, all these are approximations. The trigonometric ratio is not perfect. Now, the reason why I say that is because what you should be thinking, right, as a mathematician is, okay, I use your trigonometric ratios. I use these functions that you told me, because I basically told you, or you've been taught that sine theta is equal to the opposite of the hypotenuse. You've just been taught that. No one has proven to you that sine the angle is equal to the opposite side divided by the hypotenuse side. Where's the proof? How do you know that that is true? And this side is 58 degrees, and you know by definition this side is 30 because that's what we solved before. So I'm putting in all the information that we know, or at least that we used solving the trigonometric ratio. So we've basically solved for every unknown within this right angle triangle, right? We know everything now. And imagine we just started off with just an angle on one side, and we could solve for the other two sides and even solve for this side. However, the problem here is that you know, right, that the internal angles of a triangle should add up to 180. When you add these up, you don't get 180, right? You get 178, right? Almost 180. So I just wanted to point that out because these trigonometric ratios are not actually perfect. And one of the reasons, well, actually the only reason why they're not as perfect as, the reason why they're not as perfect is mostly because we approximate, right? We approximate. Like for this 1.7 it was a reoccurring, well, not a reoccurring, it was an infinite decimal, so it would be hard for us to. It would be hard for us to actually use this, or unless you want to use root 3, the square root of 3. But there is a way to figure out this trigonometric ratio you need to use within seconds. But I don't even need to show you guys it now that you guys are already that fast. You don't even need it. But I'll show you it nevertheless, right? There is a way to just look at it and see. And those, of course, are when you have your angles like arranged like this. All right, so again, I'll show you guys each scenario. Right? You can pick it out easily. So if you're looking at theta and you have the hypotenuse, so I'll just label this B, and the adjacent, you know the adjacent hypotenuse is cos theta. But you notice with cos theta is that cos theta is on a V, right? So if you look for this V, you'll see cos theta. Anytime you spot a V like this, meaning that you have an angle. So if you spot a V like this, you're looking at cos theta. Right? If you have an angle, the angle here and this and the two sides in the middle, right? So you have the two sides and the angle in the middle. If these are the two sides you're concerned with, the two sides that make up your angle theta, so which in other words, this creates a V, the ratio will always be cos theta, right? So, and if you look at it in this case, with Shoshana's example, right away you see this, right? You see the V, right? You see the two sides with the angle in the middle, you know that is cos theta. Because those two sides will always be the hypotenuse and the opposite. Right, the adjacents are the hypotenuse and the adjacent. So again, once you see that V, right? Once you see that V, meaning the two sides and the angle in the middle, you're looking at cos theta. Another one, again, this is the rectangle. So there are of course ones for the others. So if you're looking at a 90 degree again, the theta is over here. So the theta is over here, and you're looking at E and C. So if you're looking at an L, right? In other words, you're looking at the two sides on between your 90 degrees. So you notice this is the two sides on the 90 degree. Automatically, the trigonometric ratio is tan theta. So if you look before in Baraka's example, you're looking at the two sides on the 90 degree, right? That create that 90 degree. And you, of course, that'll be the tan theta. Matter of fact, the thing about this one is actually once you're ever looking at these two sides, it will always be tan theta, right? If theta was over here, it would still be tan theta because you'll still be looking at adjacent and opposite, right? So it would still be tan theta. So this works in any scenario. This works in any scenario. Once you're looking at the opposite, well, of course, opposite and adjacent is tan theta. But another way you can quickly go to the fact that it's tan theta is if you're looking at if the sides of interest are on that 90 degree, then automatically it's tan theta, right? So there's another, the last but not least, is sine theta. So how do you see sine theta right away? Sine theta is a bit more tricky because sine theta is like this, A and B. Right? Sine theta is like this. It's a V. It's sort of like the V, but no angle in between. Theta is not in between there, right? So if you have an angle, and the two sides you're looking at are A and B, and theta is not actually in the middle here. Theta is not in the middle. If theta was in the middle, it would be cos theta, right? But if theta was here, right? Theta would be here. If theta is not in the middle, so no angle there, then you're looking at sine theta. And you notice I'm just telling you what trigonometric ratio you're looking at, right? I'm just telling you what trigonometric ratio you're looking at. You need to remember what these ratios are. Cos theta is adjacent over hypotenuse, tan opposite over adjacent, and sine is opposite of hypotenuse. You still need to remember what those trigonometric ratios are,